In this lesson, we're going to take a look at topic 1.4, rational expressions. Looking at the objectives, add and subtract rational expressions. Combine rational expressions. Determine the restricted values of a rational expression. Multiply and divide. Simplify complex rational expressions. And simplify rational expressions. For background, as we look at this, take a moment, read it. And if you're thinking of a common word or words to describe what we're doing here, we're going to work with fractions that are in some cases binomials and polynomials and this type of thing. And the qualifier for all of this, as we see toward the bottom, is we cannot have a value that makes the denominator a 0. Those are undefined. And as we look at example 1a, we're going to go to the whiteboard to work it out. So this is a rational expression, in a sense, a fraction. It looks like a binomial divided by a binomial. The protocol to solve it would be to factor this. And as we look at the top expression, this is the difference of perfect cubes. Now there is a protocol for factoring that. Take the sign that's here, which is negative, put that there. This value, this binomial will be negative. And then these first two, well, front and end will be positive. And this middle term in the recipe is going to be the opposite sign of this. It's going to be a plus. So we set this up to factor. Now we take the cube root of this, which is x, the cube root of this, which is 2, and then continuing the recipe, we square this, multiply these two together disregarding the sign, and then we square this. And that is the recipe for factoring the difference of perfect cubes. Now, in our denominator, we see we can take out an x, and we're left with an x minus 2. And now we look for common factors. Well, this cancels out of both, so our final answer will be this over this. Now, what restrictions do we have? Well, we take our denominator and equal it to 0, and then each of these factors to 0. So if x were a 0, that would make our denominator 0, so x cannot be 0. And here, if x were a positive 2, these are restricted values. All right, let's go back to our regular board. And there is the answers right there. Now, in example B, we've copied it correctly. Let's go to the whiteboard. We want to factor our numerator. Generally, these aren't too difficult to factor. Need a negative in the middle, so this will be a negative. This will be a plus. Now, as we look at our denominator, this looks like it's in factored form already, but the signs here are wrong. So if we take out a negative 1, we can reverse the signs, and this becomes x minus 3. Now we see we can cancel this out, and our answer is this over negative 1. And we don't like to leave a negative 1 in the denominator, so we're going to make our numerator a negative 1. And this will become a positive. So our answer now becomes, as we multiply through by that negative 1, a negative x, a negative 2. Now we could have put negative 2, negative x. Let's see what the book does. Going back and then bringing this down. And we see our answers concur. Now what we didn't do is equal this to 0 here to find out which value we must exclude when there's a variable in the denominator. So if x were 3, it would make our denominator here a 0, and that is the excluded value. And they're giving us here an important caution. So pause, read this. And what they're saying, you can only cancel out factors, not terms. So these are not factors here. You can only cancel out factors. Now, multiplying and then later dividing is or was illustrated by what we just did. Now, when we are combining rational expressions, this is the challenge, because in order to do so, you must have a common denominator, and the least common denominator makes it a tad easier. So take a moment, read this over, and then we'll work these examples. Now, as we look at example 2, we'll look at A first, and I've written it here so we can use the whiteboard. As you can probably see, it gets quite tedious, and that's why I'm going to work it out in some detail. So again, you want to develop a strategy. First, what is my common denominator? Well, you figure that out by factoring your denominators here. And generally not too difficult to factor. Now here we need a positive sign in the middle, so this will be plus. This will be minus, and then the product of our last is a negative 2, and this checks out. Now here we see the difference of perfect squares, which will factor into their conjugates. Now, what's our lowest common denominator? Well, we look at the factors that we have here. Now we know we need this, so let's write that here. X plus 2, x minus 2. Now notice we have an x plus 2 here already represented. What we don't have, and I'm going to change colors for this just to emphasize, we don't have this one. So we need an x minus 1. So this will be our new common denominator. Now, what does this denominator need to become this? Well, it needs an x minus 2. So I'm going to do this here. So in order to make this denominator, this denominator needed an x minus 2. Theoretically, I could put it here, but I've put it here. Okay. Now, what does this denominator need? What factor in order to get this? Well, it needs this one. So, x minus 1 here. And in a sense, x minus 1. We now have common denominators. Okay, what's our next step? Well, our next step is we need to FOIL this, and keep in mind we can make this a plus here, make this the minus, and I'll pause while I do that here, save a little time. So, looking at it, I FOIL this and got this trinomial. And check the work. I distributed this and got this. And now notice this will cancel with this. I get a negative 5x and a positive 2x. Combining like terms, I get a negative 3x plus 2. And that's all going to be over this common denominator. And that is my answer. Let's check it out on the other board. And there it is. So it's kind of a complicated procedure with lots of steps. Need to be careful to check your work as you go along. Now, looking at example B, I'm going to go to a finer point here. There's the example. And we'll go back to red. And I would suggest that here, this negative sign, you could make this positive and just put the negative sign up there. And you want to find what is your least common denominator. So this is factored. We factor this. And again, the factoring is not difficult. Factor this. This is the difference of perfect squares. Factors into its conjugates. And notice what happens here in this middle term. The x plus 2's can cancel out. So instead of making this with possibly 3 different factors, we end up with only 2. So what's our least common denominator? It's this here. So looking at this one, which one does this need to make it this? And you might say, well, it needs the x minus 3. Again, this configuration, this is just a 1. We're multiplying this by 1, not changing its value. And then when we expand that, we get this trinomial. And this term here, it's missing the x plus 3, which is this 1. So 1. We FOIL this numerator, and we get this one here. Now, notice I put the minus up there, and this just stays the same because it already has the common denominator. We just need to change each of these signs. Where this was positive, it now becomes negative. where this was negative, it now becomes positive. This was positive, now becomes negative. Ah. So again, lots of stuff. Check your work carefully. Need to know techniques. And now you're going to, I'll clear it up, combine like terms. And the challenging part here is to double check your work. Be careful with the signs. An error can easily be made. Now, once you get your final answer, notice this can now be factored into this. And we have common factors. So after all is said and done, this is your answer. Now, when you do your practice and certify, you'll get one like this. It's going to take a while. Again, the protocol is factor everything. Find out what your least common denominator is. Multiply the resulting fractions by 1 to make them equivalent fractions with your common denominator. And then once you combine like terms, see if you can factor still, and then simplify. All right, going on to example 3. We're going to look at item A here. And let's go to our whiteboard. Now we're multiplying. Again, we'll use some of those same techniques. We're going to factor this. And I'm just setting it up here. So again, not too difficult of factoring. And I'll need a plus here and a minus there. And this is a 2 and a 1. This needs to be a negative, and this is a positive. Now you see what we're going to do. We can do some cross-canceling. This is a common factor. And that's as far as we can go. So now we have x plus 5, x minus 3, x plus 3, x plus 1. And we'll FOIL these, and that should be our answer. Let's do it together. So this is going to be x squared, positive 2x minus 15. And this will be x squared plus 4x plus 3. Let's see how we did. Okay, they're leaving it in factored form, which is what we had there. And again, you'll have to see how the software wants you to put it. Let's pause. And we'll follow the book for item B. The key is it's done in a very similar way. The main difference is we have to change division to multiplication. So the division of fractions, if you need the review, the first item stays the same. you change the division sign to multiplication, and you take the reciprocal of the second item, that is just flipping it, and now you have a multiplication problem. So you're going to factor this, which is what they've done here, and factor this. I would have left it just x minus 2. They have it squared, that's okay. And then now you're going to cancel. They're canceling out one of those. That's a little easier. Cancel the 3 and the 9 and one of the powers of x. And then once you've done all that canceling, you're left with 3x squared here, and this over your common denominator. Now notice they're not asking what would be values of our denominator that would be excluded. Sometimes they could ask that. And of course here in this final, you cannot have a 2. That would make the denominator a 0. Now for our last slide, pause. This is background. We're going to simplify complex fractions. We'll set up the first one and work it for you. Okay, what I've done is I've carefully copied what was there, but notice I changed this to h over 1. Now there is a 1 there, we just don't write it usually. But now you see this is a complex fraction over a complex fraction. Let's go to the whiteboard. I'll change colors. What we need to find out is what's our common or least common denominator here. So we're going to multiply each part, the numerator and denominator, by our least common denominator. And you can just pick it right out of here. Now, if this was other than a 1, we'd have to include that there. So we're going to multiply this by x plus h and an x. So if we did it there, we must do it here as well. This is going to be a 1, x plus h, x. Okay, so what we need to do now is multiply each of the parts of our numerator by this. Notice that here, this cancels out, and all that's left here now is x. So this will become x here. Multiplying this term by this cancels out. Now, we're going to have a minus. That's our minus here. We're going to multiply this term by this. Now here the x cancels out. So it's going to be a minus x here and a minus h. Now what I'm going to do is combine these terms. Notice the x's cancel out here. So I'll just erase them. And I'm left with a negative x in the numerator. But now I had to multiply my denominator. And I'm just writing it out like this because notice what happens. And keep in mind that there's a 1 up there that we don't write. It's in a sense in the front here. That I'm going to cancel now this h. And I'm left now with a -1 over x times x plus h. Now, theoretically, I should multiply that through, but I believe they will accept this answer. Let's go to the regular board, clear this up, and check it out here. Yes, this is what they're getting for the answer. All right, we'll go on to part B shortly. Now, I could use the book's values for these, but I'll go over it. I think that works better. So I've copied it. Let's go to the whiteboard. And right now it doesn't look like complex fractions. But to put it in the complex fraction form, x to the -1 is actually 1 over x minus 1 over y. The rule of bringing the negative exponent down to the denominator changes the sign, and the same here. 1 over x to the second minus y over 1 over y to the second here. Let's write that properly. So what would my common denominator be here? Well, to get rid of all these, I'm going to have to multiply this by x to the second, y to the second, x to the second, y to the second. Let's put it down here. Let's do our denominator first. So here, as I multiply this term by this common factor here, least common denominator, the x to the seconds cancel out here, and this becomes y to the second. This one cancels, I'm left with that. And this will be minus. Now here, x to the second cancels, so I get, I should say y to the second, I end up with x to the second. Okay. And then here, this will be, one of the x's cancels here, and I end up with x y to the second. Here, one of the y's cancel out, and I get x to the second y. Now, I can factor this a little more. I can take out a common xy out of these, and I'm left with y minus x. And this is the difference of perfect squares that will factor into its conjugates. And then now here's a common factor. So my final answer is this. And let's check it out. Yes. Okay, this will wrap it up. You're going on to practice and later certify, and hopefully this is helpful.